If you haven't watched the Doppler effect video, make sure you watch that first because this expands on that. Now we're going to start talking about red shift and blue shift. So as we saw before, quick overview. If an object is emitting a sound and it's coming towards you, like a car with a horn, since the car is moving toward you, the speed of the car is squishing the wavelength of the sound, making it higher pitched. Now, if it's going away from you, it'll do the opposite. It'll stretch out the wave, making it lower pitched. And if you could see that, you know that as a car passes you, it's coming towards you, you'll hear higher pitched like this. Beep, beep, beep. And then as soon as it passes, beep, 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 beep. And if they increase speed, the change will be even more drastic. But let's move on to light. Not only does that happen with sound, but it can happen with light as well. Let's say you look up in space and you see something, something emitting light out there. Say it's a galaxy far, far away. If that galaxy, if you could be with that galaxy and it is the color green, then that color green light will be getting emitted straight to you. If you can see the color, that means that the waves are coming into your eyeballs. If that galaxy or that thing in space is not moving, then the color it is, those waves will not be stretching or compressing from like the Doppler effect. They'll just be hitting you and showing you the color that it is. But as we are learning now, the universe is actually expanding and everything in it is moving away from everything else. So this galaxy that you would see in reality, if the galaxy is moving further and further away, it's hard to show movement on a picture, but let's say it's moving further away. The green light that it gives off, it is still green, but since it's moving away as it's emitting that light, those green light wavelengths would be stretched out and become longer. Now those light waves would then, to you, look red. So when you look up at this thing, it would actually be green, but since it's moving away as it's emitting the light waves, the light hitting your eyeball would look red. Now, if you understand the electromagnetic spectrum, that'll help you understand this a little more. If this thing in space, this galaxy, is not moving and you're seeing green, then the wavelengths are about, let's just say they're about 540 nanometers, right? But if this thing in space is expanding with the universe and moving away, then those light waves that it is emitting are being stretched, just like the Doppler effect, right? They're being stretched. It's moving away from you, so they're being emitted and stretched from that movement. And so what you actually are seeing is longer waves. As they stretch out, longer light waves, when they stretch from green, they could stretch out to about 650 nanometers and become red. That's what we call something is redshifted. Redshift just means that the color, emitted has shifted toward the red end of the spectrum. The red end of the spectrum. You should write that down, although there will be another chance for you to write it down. So let's not get this confused. Let's think of a different example, right? Let's say you're looking at something that is blue, except it's moving far away. Sorry, it's moving away as it's emitting that blue light to you, so it gets stretched out to over here. Something that is actually blue in the sky, so you're looking at this one. If it was stationary, it would release these blue waves to your eyeball. But if it is moving further away as it's emitting that light, those waves could get stretched to look like they're green, right? They're going from a shorter wavelength to a longer wavelength. Redshift doesn't mean it always looks red. It just means that the light is shifting towards the red end of the spectrum, right? Because there's a red end and a blue end. So if something is red shifting, it's moving away from you. Now think of the opposite. Let's say that something is moving towards you. Well, which way would it be? right? Let's erase some of this. Let's just click back a million times. If something is moving towards you, then it would be the opposite. It wouldn't be red shifted, it would be blue shifted. And as I'm erasing this, you can think of, well, why would it be called blue shifted? Well, let's go back to our first example. Let's say you're looking up at this thing in the sky and it looks green to you. Well, now let's say that thing is actually moving closer to you. It's moving at you as it's emitting that light. Well, what will happen is those green light waves that it would emit if it was not moving, as it's emitting those light waves at you, but it's moving towards you, they're going to get compressed and they're going to look more blue. Because if it has green light, say 540 nanometers, if you could move that thing towards you, the light would then get squeezed together and look more blue, a shorter wavelength. It's pretty crazy. Now remember, that just means that the light is shifting towards the blue end, right? That's blue shift. And I'll write that down too. Blue shift, I'll type it for you, is when the light emitted from an object is squeezed, compressed, and appears more, I shouldn't say appears, and is in the wavelength shifted toward the blue end of the spectrum. Doesn't mean that the thing emitting the light in this example isn't green. It just means that since it's moving towards you, as it is emitting that light, those light waves are getting squeezed and appearing to you to be a different color. Now, just like the last example, if you see a red object in the sky and it moves towards you and emits light, it could look more orange. If blue shift doesn't mean it always looks blue. It just means that the color has been shifted toward the blue end, towards the shorter end.